All right, hello, statistics people. We are moving on today to actual regression lines, so that's exciting, but just kind of a quick recap of what we've done so far. So you guys started by looking at scatter plots, and you should at this point know how to make a scatter plot, and you should also know how to describe the scatter plot. And remember, when we describe scatter plots, we're looking at form, direction, strength, and then if there are outliers, we need to mention that there are outliers. You guys also looked at this thing called correlation, or R, and this R value tells you the direction and the strength. It gives you a value that both measures direction and strength. So today we're going to kind of continue on with this, and we are going to talk about, okay, I have my scatter plot. This is great. Who cares? What do I do with this? And so today we're going to kind of look at, okay, well, what do you do with this? So let's kind of start here. I'm going to draw a little sketch for you. You do not have to copy it, but just kind of check it out. So you have your scatter plot. They look something like that. The scatter plot is nice and all, but it's not really useful to actually do anything except for maybe to describe the relationship between the X value and the Y value. Another thing you may want to do with scatter plots is you might want to actually say, take an X value, particular X value, and you may want to know, hey, with a particular X value, what's the Y value that would match with that X value? So for example, if I were graphing height and shoe size, so if my X value was height and my Y value was shoe size, I might want to know, okay, what about a person who is 5 feet tall exactly? What would their shoe size be? And maybe on your scatter plot, you don't actually have a person who's 5 feet tall. So there's no X value for 5 feet tall. So you might want to try to predict a shoe size for that height, even though you don't actually have a dot that does that. So how do I predict Y values from a scatter plot? Well, the way we're going to do that is we're going to actually use an equation of a line. And this line is going to hopefully fit kind of halfway in between as many of these points as possible. Okay? That line that we're trying to fit with the data is called a regression line. It actually has a million different names, so I'm going to give them to you now. So regression line is one of the names. Another line, so AKA, this is also called the line of best fit. What happened to the E? It like became an S. So line of best fit. It's also called the least squares regression line. They all mean the same thing. So a regression line, or a line of best fit, excuse me, is a line that helps predict Y values from given X values. So is a line, and it's going to also be obviously an equation, so a linear equation, that helps predict Y values from X values. Okay? And so I'll now show you an example of what I mean and why it would be convenient and nice to have an equation to use rather than just eyeballing it with a scatter plot. So here is our example. And I don't know, I'm sure you guys kind of have done this naturally, but just in case, if I'm writing too quickly or going too fast, please feel free to pause the video for you guys to catch up. Totally fine. I mean, I'm obviously not there to enforce it, so really everything is fine. Okay. Mr. Brissett was interested in buying a particular used truck, so he checked his TrueCar app for the trucks in the area, which gave him this table. And as you can see, the table shows miles driven for each truck and the price in dollars because, and maybe you know this, maybe you don't, the more miles a car has driven, the lower the value of that truck will be because it's worn down, it's not going to work as well, etc. So if you notice, This truck right here with only 8,000 or so miles is worth $30,000, whereas this truck with 100,000 miles is only worth $9,500. So in general, the more miles driven, the lower the price is going to be. Okay, so they give you this table with several different trucks, and evidently they were too lazy to write that line to continue it there, but alas. So we have that table. Let's move on. He then made a scatter plot showing the data and found a regression line to help him predict the price from miles driven. Here's why this line is nice. So he made a scatter plot, and then he found the equation of a line that, as you notice, is kind of in between as many of these points as possible. It's sort of in the middle of all of these points. So that's nice, Brisette. Who cares? Well, here's the deal. These are just a few trucks shown. Presumably there's a bunch of trucks for sale. What if, and don't write this down, just watch. No. What if Mr. Brisette finds a truck with 100,000 miles on it? And what if this truck is for sale for $25,000? So a truck with 1,000 miles on it, it's for sale for $25,000. Well, do I know if that's a good deal or a bad deal? Well, not really, because as you notice from the table or also from the graph, there aren't really any points in the 100,000 mile range. So I have no idea. I can't really gauge if that's a good deal or not unless I look at this line that's been created. And then as you see at 100,000 miles, it looks like a price that goes with that should be right around like $20,000, $21,000. So then that would tell Mr. Brisette, okay, well, this truck that's for sale for $25,000 with 100,000 miles on it, that's a little high of a price. So maybe I won't buy that truck. So as you see, if I didn't have that line here, if I just had the scatter plot and I found a truck for $100,000, the scatter plot alone isn't really going to help me. That's where I would like to actually have an equation of a line or an actual line drawn to help me decide what's a good price for this truck or not. Or in other words, to help predict a Y value from a given X value. Okay, so that's sort of the whole point of a regression line. So now let's actually get into what you are going to have to do with it. Okay, so now you can go ahead and write down what I write down. Okay, so the equation for the regression line shown is predicted price equals 38,257 minus 0.1629 mile times the number of miles driven. Okay. So what are you going to have to do with regards to regression lines? Well, you're going to have to, given data, create a scatter plot, which you should be able to do. Eventually, you are going to be responsible for finding the equation of a regression line yourself, but we're not there yet. What we're going to start with right now is we're simply going to start with identifying the parts of a regression line. So here's the deal. Back in the day in Algebra 1, you used to use this equation for a line, y equals mx plus b. So take like a half a minute right now. What is m, what's b? Tell your people. Go. Okay, let's see if we got it. So kids, what's m? That's right, it's slope. And what's b? That's right, it's y-intercept. So this was the traditional equation, general equation for the formula for a line. We have a very similar equation in AP Stats, and unfortunately, we don't use this at all. Not only that, but b is going to mean something totally different. So our equation for a regression line is actually y with a little caret thing on top of it equals a plus bx. Okay, so let's start with the frustrating piece of this. So back in the day, b used to be the y-intercept. But actually now, because it's the thing that's being multiplied with your x value, b now is our slope, because stats hates you. Okay, so B is actually our slope, which means that A, you guessed it, is actually your y-intercept. So our new equation for a line is y with this little caret thing equals a plus bx. And actually y with the caret thing has a name. This little caret thing kind of looks like a hat, and in fact, that is what we named this variable. It's y hat. Yes, y hat. It has a hat, indeed. So y hat equals a plus bx. That is the general formula for a linear regression line. Okay? So let's talk about what this y hat thing is. Well, look up here to the equation that they're given. I don't see any x's or y's, but there are certainly variables. If you notice here, your y hat is actually the predicted price. And that is because your y hat is not actually a y value, it's a predicted y value. And then if you notice miles driven, if you look at the actual scatter plot, the x variable, of course, is in fact miles driven. So, so in this particular case, your predicted price is your y hat and miles driven is your x, which means what value of these remaining numbers is your slope? It's this guy. Negative 0.1629, and according to this equation here, that means the y-intercept, of course, must be 38,200 and, well, that's a horrible 257. Okay. So that's nice, Bruce said, who cares? Well, one of the things that you are almost certain to see on the AP test is they're going to give you some kind of a linear regression equation, and they're going to ask you to interpret the slope. And you, in theory, should have done that a little bit in Algebra 1, but I know it's been a while, so we're going to remind ourselves how to do that. But also in stats, there's almost like a formula of sorts you could sort of follow for this. So here's what you're going to say. So the way that we interpret slope goes like this. So for each, yes, word, that's what I wanted, really. Okay. So for each additional unit of whatever the x variable is, the y variable is predicted to either increase or decrease depending on the slope itself and the scatter plot and the whole situation. Oopsie. Decrease by whatever the slope is. Now, I'd like you to underline a couple of things. If you have a different color, that would be ideal. I'll go orange. Okay. So when you are asked to identify or interpret the slope, actually some of these are interchangeable. So for each additional unit of x variable, that is interchangeable, and you're going to need to put that in context. The y variable also needs to be put in context, is predicted to, and then increase or decrease is going to depend on what the slope is, and then of course by the slope itself. So everything I underline in orange, you need to put in the context of the problem. Okay, so I'm going to show you what I mean by that using this example of miles driven and price in dollars. Okay, so if you want to, go ahead and pause the video right now, and I essentially want you to fill in each of these orange blanks with the information from this scatter plot and this equation in context. So if you feel like, yeah, I think I got that, let me try it, go ahead and pause the video and try it. If not, let's keep going. So when I'm interpreting the slope for this particular problem, I'm going to essentially just fill in the blanks with the context from this problem. So I'm going to start with interpret the slope, okay? So I'm going to start with what I'm starting with. So for each additional unit of the x variable, okay? Well, let's talk about the x variable. The x variable is miles driven. So for each additional mile driven is what I'm going to look at. So for each additional mile driven, that's my unit of x variable, miles driven. Okay, well, what is the y variable? Because that's what I'm supposed to fill in next. The price in dollars. So I'm going to say the price of these trucks. You don't even have to say of these trucks. I just like to throw in more context for funsies. So the price is predicted to, now in this case, are we increasing or decreasing, and how do you know? That's right, you're decreasing. You're decreasing in this particular case because the slope is negative. And let's just common sense this for a second. For each additional mile driven, so the more miles you drive, the lower the price is going to be. So in other words, the price is going to decrease. But again, I knew that. I can know that from looking at the slope. So the price of a truck is predicted to decrease by the slope. Well, what is the slope? In this case, it's negative 0.629. So now I'm just going to say what the slope is, but be careful. Notice how I've already said decrease. Because I've already said decrease, I can't just plug in the slope as it is, because that negative is sort of doing double duty here. Because I've already said decrease, I do not need to actually write the negative. So it's going to decrease by 0.1629, and then I need to put this in context. So I need to give this a unit. So 0.1629 what? Well, look at your y variable. What's your units? It's dollars. So by $0.1629, or in other words, for every additional mile driven, the price of a truck is predicted to decrease by 16 cents approximately. So for each extra mile you drive, the value of your car is going to drop by 16 cents. That's what this sentence is saying. Okay. So if you feel like, yeah, I can come up with that, I can say that, I don't really need to follow the scripted this scripted sentence, then that's awesome. If, however, you like to kind of fill in the blank with scripted sentences, then you are literally going to write this sentence and fill in the orange blanks each time with details from the problem. With me? Okay. You're going to practice a little more in a little bit. My child isn't breathing, so let me actually go make sure he's alive. Pause. All right, he's alive. Victory. Okay, moving on. So that's how we interpret the slope. Okay. Well, you're also going to be asked to interpret the y-intercept. I'm pretty much guaranteeing that on the AP test somewhere you will have to interpret slope. Very likely you will probably have to interpret y-intercept, but it's not a certain, it's a maybe. You will certainly have to interpret the slope. So, how do you interpret y-intercept? Well, I'm actually going to argue that you've done this before, so let's chat for a second. Discuss with your group here. Look at your graph. Whoa, whoa, whoa. What was that? What just happened? How do I undo? Hold on. Pause. Never mind. No time. Okay. So, what is the y-intercept of an actual... Oh, my gosh. Microsoft Word. Seriously. I want to punch you in the face. Yes, I do. Okay. So, what is the y-intercept of a graph? Like, where is it? Okay, well, the y-intercept is quite literally where the line crosses the y-axis. So at that point where the line crosses the y-axis, what's your x value? Well, for my algebra-ish people or my calculus-ish people, x value there is 0. So how do you interpret the y-intercept? Well, it's pretty simple. It's whatever the y value is when x is 0. So when the X variable is 0 units. The Y variable is predicted to be, the y-intercept, whatever that is. Good Lord. And again, we have sort of a fill in the blank here. So when the X variable is 0 units, that part is a fill in the blank and it needs to be put in context. The Y variable also needs to be put in context, is predicted to, that's not supposed to be by, that's supposed to be B, the y-intercept, whatever the y-intercept is. Okay? Side note here. Sometimes your y-intercept is actually not going to be a value that makes sense. So even though you're going to be asked to interpret the y-intercept, it might not actually make any sense whatsoever in context. The interpretation we're about to do, that y-intercept is going to make perfect sense. But in other problems, the y-intercept might not actually make sense. So just kind of a side note, y-intercept, intercept, sometimes doesn't make sense. In context. Sometimes, not all the time. All right. So let's look at that in this context. So interpret the y-intercept of the regression line relating predicted price of the trucks to miles driven. Well, if you look back up to the graph, and I'm not going to even try to scroll up, or the equation, you're going to notice that the y-intercept is the first number in the equation, which is 3,000 or 38,000, right? Yeah, 38,257. Which means when X is 0, the Y value is predicted to be 38,257. So what does that mean in this context? What does it mean for a car to have 0 miles on it? Well, it means it's brand new. So what this is essentially saying is when a truck is brand new, it has 0 miles on it, the starting predicted price should be about $38,000. Does that make sense in context? Well, sure, of course. So that's what we're going to say. But again, if you want to say the price of a new truck is predicted to be 38,257, that's perfectly fine. But if you want to follow my kind of fill in the blank sentence to do this, that's totally fine too. That's what I'm about to do. Okay? So I'm going to say when the truck has 0 miles driven, and in parentheses I'm going to put brand new just to tell the reader that I know what that means. The predicted price is $38,257. That's it. I evidently forgot to write the word truck. So when the truck has 0 miles driven, so when the X variable is 0, the Y value is whatever the Y-intercept is. Okay, notice, when I'm interpreting slope and when I'm interpreting Y-intercept, I have the word predicted. If you do not include the word predicted, you automatically fall to partial credit on an AP test. So when you are interpreting slope and Y-intercept, you are always, 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 always predicting. Do not forget the word predicted. Because if you don't, what you're saying is when a truck has not been driven, its price is $38,000. You're saying definitely, certainly, its price is $38,000 when that's not true. Unless I have an actual truck in my list of data with 0 miles that is $38,257, what I have just said is not true. So I need to make sure I use the word predicted. The truck is predicted to be 38,257. It's not definitely 38,257. Cool? Okay. And then finally, one of the kind of basic things you're going to be asked to do with a regression equation is the following. So use the regression line to predict Y values. Example, Mr. Brissett found another truck in LA that has exactly 20,000 miles on it. Using the model given, what would the predicted price for this truck be? So our model given was predicted price, and I'm way too lazy to write that, so I'm just going to write Y hat instead, is equal to 38,257 minus 0.1629 times miles driven. Okay, so I have a truck with 20,000 miles on it, and they want to know what the predicted price would be. So what do? That's right, kids. You plug in 20,000. That's it. So I'm going to go ahead and do 38,257 minus 0.1629 times 20,000. I'm going to go ahead and plug that into my calculator to get an answer. So go ahead and pause this. Take a second to do that. And after you have paused this, you should have gotten 34,999. Yes. So $34,999. Okay. That's an extremely common question, and hopefully, guys, this was really easy, because I guarantee you when you see this question again in even in a couple sections, you're going to forget how to do it and you're going to freak out, and the answer is always easy and you always feel silly because you're like, oh, I didn't remember that's what that meant. Yeah, guys, if they ask you, hey, what is the predicted whatever, and then they give you a value, it probably means plug in that value to X and then get a predicted Y. Done. Okay? And then finally, the last idea we have to talk about is, I mentioned that sometimes y-intercepts don't actually make sense in context, and that's because of an idea called extrapolation. So let me sort of explain. I'll go to our model that I evidently wrote all over because Microsoft Word is stupid. I'm just going to erase all of it. Okay. All right, because you already have this written down, presumably. Haha. Okay. So I have my model. This is great. I want to use this model to predict the price of a truck. Well, what if I find a truck, I don't know where, that has 705,000 miles on it? Okay. Well, if I have a truck that's 705,000 miles, if you notice, this graph only goes up to 160, and this line is going down pretty fast, right? So if I tried to plug in 705,000 to this equation, to the model that I have, what would happen? Or if you want, go ahead and do it. What happens when I plug in 705,000 miles in for X? Well, you should get a negative value, which basically would mean that the value of the truck would actually be negative, which would mean you would have to pay somebody to get rid of the truck. Which presumably actually would probably be true if you're selling it for parts, maybe, but maybe not. I don't know. Either way, you're not going to be paying whatever it says for the truck. So extrapolation goes like this. Whenever I have a value that I would like to plug into the linear model, but this value is well outside the range of the data, meaning my data only goes up to 160,000, and I'm trying to plug in 705,000. That's way out of the range of the data. Well, whenever I try to do that, I will most likely get an answer that's totally bogus, that doesn't make any sense, because I'm incorrectly plugging in a value to a model that's inappropriate. So let's talk about that. Or let's write that down. So this is the use of a regression model to predict a Y value from an X value that is well outside the range of the data. So it's the use of a regression model. So I'm using the equation that I'm given to try to predict a y value from an x value that's way outside the range of the data. So it's not just outside, it's way outside. If you remember from the graph stops at 160,000 miles. If I want to know the price of a truck that's 165,000 miles, that's fine. You're not really extrapolating at that point because that value, even though it's outside of the range of the data, it's not well outside the range of the data. And so the deal with this is, it is inappropriate to do that. So the only x values you should be plugging into an equation should be x values that fit within the range of the data. So going back up to our graph, it would be totally appropriate to plug in any truck miles between 0 and approximately 160,000. So any values in between those two values would be totally fine to plug into this equation. But the higher you get above 160,000, the less appropriate it becomes to plug into the model because the model might not work anymore. We only know the model works for the data that we are given. We don't know what happens after this data. So for example, if you look at the actual scatter plot itself, it's pretty linear. I mean, most of these points are going downward in a pretty constant rate. But what I'm guessing is going to happen is after this point, I am guessing what this graph is going to do is it's going to have points that kind of go like this, and they actually are going to, I'm assuming, curve and just stay kind of flat at the bottom because eventually the trucks will be worth nothing. And so even though your data started off nice and linear, kind of going down in a straight line, it eventually is probably going to curve. And so after the range of the data, a linear model is no longer appropriate because the data is going to kind of curve and everything's going to be basically worth nothing because it has so many miles on it. So the moral of the story is the higher the number outside of the range of the data, the more you don't know if those numbers still actually fit the overall pattern of the original data. So let's write that and then we are done. So would it be appropriate to use the model above to estimate the price of a truck with 200,000 miles on it? Remember, 160 is where this stops. Is 200,000 miles okay? I'm going to argue no. 200,000 miles looks like it'd be, so they'd be like 180 would be here, 200,000 would be here. No, that's kind of far away from the rest of the data, I would say. So here's the answer they're looking for. And by the way, you can pretty much copy paste it because this is the same every time. So I'm going to say no because 200,000 miles is well outside the range of the data. And then I'm going to follow this up with the linear model or the linear equation. The linear equation may not work for data that far away from the original values. Okay, so so no, because 200,000 miles is well outside the range of the original data. The linear equation may not work for data that far away from the original values. That's all you're saying. So by the way, model is also another word for linear regression. So linear equation. So whenever they say, hey, does the model look good? Does the model work? They're saying, hey, how's that line looking? Is it pretty in between most of those points? Is the equation a good one to represent the data? So would it be appropriate to use the linear equation to estimate the price of a truck with 200,000 miles? No, because 200,000 miles is outside of the range of the data. The linear equation may not work for the data that far away. This entire thing is a full credit answer. If you stopped here, you just had that first sentence, you would get partial credit. And almost every year, every group of students I ever have usually just stops at that first sentence. But you've got to say more. You've got to say, you can't just stop at, well, it's outside the range of the data. Well, why is that a problem? Well, it's a problem because we don't know if the linear equation still works outside of the range of the original data. Okay? All right, folks. So you got slope, you got y-intercept. You are sometimes going to be asked to plug in values to your linear equation to give you a predicted value, and occasionally they're going to ask you to plug in values that you should not plug in, and that is called extrapolation. Okay? All right. Have a lovely day.